Okay, so number 28 says find the indefinite integral. Remember to use absolute values where appropriate. And that's what we were talking about as far as the denominator power being 1. Okay, so looking at this, let me get your brain knowing what you're looking at. We're going to do a U-substitution. And the biggest reason why we're going to do a U-substitution, very closely related to what we just spoke about with the other problem, is the fact that this coefficient of this variable, think of theta over 5 like x over 5. They're both variables. What's the coefficient in front of theta over 5? 1/5. It's not 1. And because it's not 1, we want to make it 1 by doing a U-sub. So u would be theta over 5 du. What's the derivative of theta over 5? Think of constant multiple rule. 1/5 d theta. Yeah, 1/5 d theta. So if I'm looking at it like this, it's like 1/5 times theta. Remember, constant multiple rule, go put that near the door. The derivative of this is d theta, and multiply that 1/5 back in. So that you get 1/5 d theta. Alright, so this 5, this 1/5, if I multiply it to both sides as 5, I get 5 du is d theta. Now, in my original problem where I used to see this d theta, I'm not going to replace it with 5u, or 5 du. So let's put the rewrite, 5 du, and now I just have to account for cotangent of what? U. Now look guys, it was really good timing in the questioning that Bella had as far as identifying the power and the coefficients of my variable. What is the coefficient of u right now? It's 1, and that's what we wanted it to become, because I know the antiderivative of cotangent of a variable, or the tangent of a variable, so on and so forth, and u is just another variable. Okay, so what we're learning in this unit is more manipulation of my integrand and using the techniques that we've learned. U-substitution, rewrite, different things like that. Can you tell me the integral of, right now, do you have memorized the integral of cotangent of x, or cotangent of a variable? Okay, so I know that cotangent's derivative is negative cosecant squared. I know its derivative is negative cosecant squared. But what I'm asking is, do we know the antiderivative from this? The answer should be what? No, we don't know. Okay? But what we can do with what we've recently learned is we can change this to an equivalent of cotangent of u. So think of cosine and sines. How do I write cotangent of u? Cosine of u over sine of u. This is the same as cotangent of u. This unit is really big on trig identities. Okay? So, using the techniques that we just talked about with natural log, I could do a U-substitution again. Do you see what I'm doing? Where my U-substitution now is going to be, let me make some room. What will my U-substitution be, guys? U is equal to what? Cosine of u. And you see how I chose the variable u? It doesn't matter what variable I choose, just don't get mixed up, okay? So I have cosine, not cosine, I'm sorry. Not cosine. I should do what? Sine. Because what is now the differential of each side? What would the derivative of the right side be? Cosine of u du. Now watch. All of this is right here that just got picked up. So when I rewrite it, it's going to be du is on top over my u assignment of sine, and what's out in front?
3 or 5.
The 5. And some of you may write it like this, and some of you may write it to where you have 1 over u du with the 5. Now we just talked about this. 1 over something that has a coefficient of 1 and to the power of 1 will always, always, always be the natural log of the absolute value of whatever that is. Constant multiple, roll this 5 back in and do a plus c. Now, what is it that you have to do next with your answer? You have to substitute this. We plug this back in to where it becomes 5 times the natural log of the absolute value of sine of u plus c. So we used our U-substitution twice. So we're going to have to replace it twice. So this right here, the first time, we're going to put it here so that your final answer is sine of theta over 5. This is a really good problem to go over, by the way. And you get this. Any questions? Yeah.
Can you use a different letter?
Yeah, you can use whatever letter you want. U-substitution, they just pick U. Okay, you could be M, you could be theta, it could be whatever you want.
Maybe I got like a test or something.
Yeah. Even on the AP exam, what we talked about recently, yesterday, or last class, g prime of x is equivalent to f of x with second fundamental theorem. Even if you put, instead of f of x, you put m of x, but it should have been f of x, they'll just say you misspelled m or f, whatever. You know what I mean? Just keep track of your variables. Any other questions?